Good afternoon, ladies and gentlemen. Before I start, I would just like to thank Metal Bulletin for convening this conference and for affording Core Consultancy opportunity to take the graveyard shift and address you at this forum. For those of you who are not yet acquainted with Core Consultants, we are a focused mining consultancy offering high-end customized research reports, feasibility studies, due diligence, and market entry studies and assurance. We also provide corporate cultural consulting services, which involves negotiations with local communities with respect to concession rights, relocations, and confronting cultural disparities. This year, we launched a number of subscription reports and in-depth studies. These titles include ferrochrome and stainless steel, rare earths, an upcoming iron ore quarterly report, as well as in-depth study of the Sino-African relations in the mining industry, which we will undertake with the Beijing Axis. I've been requested to provide information on how reductants will continue to affect ferrochrome producers, and have been asked to address three issues. Namely, how the sulfur and ash content will continue to cause problems into the future, how the Chinese metallurgical market will continue to set prices and cause issues for South African ferrochrome producers, and lastly, to provide some direction on the coke market and the role China is expected to play on influencing this outlook. So on that note, let's kick off with the first question. Let me start by saying that in the face of rising inflation and direct mining costs, rising energy costs, a strong rand, and typically lower grade UG2 chrome ore, ferrochrome producers are no doubt under pressure. A cost analysis of the chrome ore reduction has therefore become absolutely critical in today's competitive environment. Much of the costs associated with reduction depends on the quality of and various ratios in the actual chrome ore, with the latter having a direct impact on the electricity consumption, optimum efficiency, and furnaces. With respect to the content of chrome ore, the deeper seams contain more sulfur compared to the LGs and MG reefs. In the case of UG2, chrome ore is mined as a byproduct of nickel from nickel sulfide ores, and therefore it can naturally be assumed that chrome ore itself has a higher sulfur content than previously mined chrome ores. However, in isolation, this is not a factor that critically affects the ability to produce ferrochrome. More critical is the sulfur introduced from reductants. A coke with a content of 0.6 to 1% will deliver a metal with a sulfur content of 0.014 to 0.025. For desulfurization, higher temperatures are needed, which means higher energy utilization and increased energy requirements. However, in general, slightly higher sulfur levels are not a train smash, as stainless steel makers can generally manage to desulfurize the product themselves. The highest discount that has been reported to me due to the higher sulfur content is about 1 cent per pound. Excuse me. That generally ferroalloy producers are confident that the sulfur levels in the reductants have not caused their products to be off-spec in any way. In addition, while the ideal reductant is undeniably coke, the price of coke is virtually prohibitive if one were to use 100% in their manufacture. We will discuss this issue of pricing and market outlooks in a bit. Suffice to say, very few producers run on 100% coke. IFM, for instance, is estimated to run on a blend of 40% anthracite, 40% coke, and 20% char. And then the danger comes is that if you move to a lower quality reductant, the ash component starts to become critical for the process. In general, ash is not a problem in the South African market, as it goes into the slag component and forms part of the smelter. According to Mintex, sometimes the higher ash content can actually act as a flux in the smelting recipe and then take the place of some of the quartz. The main issue with respect to ash is an economic concern, as one pays per ton of coal, so one would prefer a higher fixed carbon content. But as far as a metallurgical concern, I do not think that this is an issue. The biggest problem which producers face insofar as reductants is concerned is outside the scope of what I've been asked to present, so of course I'm going to say it anyway, and that is the availability of low phosphorus coal. In general, as I mentioned, stainless steel producers are able to manage sulfur levels themselves, but there is no process to enable them to remove phosphorus out of the stainless steel without simultaneously diluting the chrome content. Therefore, stainless steel producers mainly look for low phosphorus ferrochrome. Manganese producers, on the other hand, can tolerate a slightly higher phosphorus level and therefore slightly higher phosphorus containing reductant, which is why the wangi coke is often consumed by manganese producers, because the amount of manganese required in stainless steel is much less, and therefore the concentrations of phosphorus in manganese don't matter as much. In general, however, producers are struggling to find cost-effective, high-quality reductants. I do not believe that this is necessarily a South African phenomenon, but the difference in South Africa, as we will discuss later in this presentation, is that our coke prices track international prices, especially the Chinese prices. And China, as we know, is no longer considered the benchmark for world coke prices since introducing their export quotas. We turn now to the second question, that of how the Chinese metallurgical coke situation will continue to set prices and cause problems for South African buyers. ArcelorMittal South Africa is the largest supplier of coke in South Africa, accounting for around 84% of the market. The balance comprises coke from wangi in Zimbabwe, mainly for manganese producers, as I indicated, and then there's also imports from other SADC regions, such as the DRC and Zambia, and then limited material from the international market. Suffice to say that ArcelorMittal South Africa has a lion's share of the Southern African market, and then can reasonably be assumed to be the price setter, and indeed is the price setter. Southern Africa's coke prices track China's export coke prices. In 2008, China began restructuring its coke industry, hiked coke export tariffs from 25 to 40%, and simultaneously levied an export quota. The upshot is that Chinese export coke prices, and therefore South Africa's coke prices, are uneconomic when compared to world domestic coke prices. The exception being Northern Europe and Indian domestic prices, which are now more or less in line with South African prices. If we were to now consider that South Africa's coke tracks the Chinese landed price, then this year the South African domestic coke prices have averaged between 3,100 and 3,250 Rand per tonne ex-works, or $410 to $433 per tonne excluding freight charges. Add to this around 100 to 350 Rand per tonne freight charges, and then this represents an average premium of approximately 15% above coke procured in other countries. The question is, why then does the ferroalloy producers continue to buy from local producers? The first obvious answer is that in general, one cannot land the coke here, especially Chinese coke, and transport it to one's operations for less than you can buy it from ArcelorMittal. Larger ferrochrome companies, who I shall not name in this forum, have managed to diversify some of their requirements, mainly with Russian coke. Secondly, there is less risk in buying from South Africa, as the payment terms, while varying from customer to customer, is fairly favorable in that prices are set 1 month in advance and is applicable for the quarter, which provides a certain amount of operational stability, and also payment to ArcelorMittal in general is only required after delivery, providing especially smaller companies with a more positive working capital cycle. In our quarterly ferrochrome report, we present a cost analysis dividing producers' costs into reductants, ore, energy and other costs, which mainly include labour and depreciation. In terms of reductant costs, we estimate that South Africa ranks the 4th highest against major producing countries. As a percentage of contribution to costs, on average, reductants contribute 25% to ferrochrome producers' overall costs. This compares to other countries whose average reductant costs comprise around 19 to 20% of overall costs. Despite this, however, we do want to emphasize that South Africa is still a competitive producer on an absolute cost basis with respect to ferrochrome production.